Area of irregular figures. Remember that irregular shapes or irregular figures are shapes that consist of varying lengths. In other words, not all the sides are equal. Usually, when referring to area, irregular figures consist of 5 or more sides. Why do you think that this could be true? Take a moment to pause the video, and when you're ready for the answer, unpause it. Again, usually when referring to area, irregular shapes consist of 5 or more sides. Why? Well, the area of a triangle, or a 3-sided figure, is always the same. It's 1/2 base times height. In a quadrilateral that contains some sides that are congruent or equal in length, and or parallel sides, those quadrilaterals have special names and their own formula for calculating the area. For example, a parallelogram contains 2 pairs of opposite sides that are parallel and congruent, and its area formula is A equals base times height. So usually when we have irregular figures, we split them into smaller, more common shapes, such as this. This is a hexagon because it has 6 sides, but it's not regular. But we can absolutely draw some dotted lines across to split it to be 2 triangles and a rectangle. Another option would be to add on to the original figure to make a more common shape. Here we have a pentagon with a right angle. If we extend the sides out, we create a rectangle or square going around it based on the measurements. Here's the first method for calculating the area of irregular figures. Step number 1, divide the irregular figure into smaller figures that you know how to find the area of. So in this hexagon, if we draw 2 horizontal lines, we create a triangle, a rectangle, and another triangle. Label each small figure and label new lengths and widths in each shape, and then find the area of each shape and add up the areas, and label your answer with square units. Find the area of this figure. Well, using this first strategy, we are going to draw a dotted line across our diagram to split this irregular figure into 2 or more shapes that we know how to find the area of. So if we were to actually split it by drawing a horizontal line right here at this 2-meter mark, we create an area 1 on top and an area 2 down low at the bottom. And we have 2 rectangles. And the area of a rectangle is length times width. So the length and width of area 1 are 4 meters and 2 meters respectively, and the length and width of the second rectangle is 12 and 6 respectively. So let's multiply each pair together. So for area 1, you would do 4 times 2 and get 8 square meters. And for area 2, you would do 12 meters times 6 meters to get 72 square meters. And then if we add up 8 square meters and 72 square meters, we get 80 square meters as our total area for this irregular figure. Here's the second method for finding the area of irregular figures. Step 1, create one large closed figure. So take this pentagon that has 1 right angle and extend the sides up and around to create a rectangle around it. Label the small added figure and label the new lengths and widths of each shape. Find the area of the new large figure, so the area of this rectangle, and then subtract the small areas of these triangles in this example out of it, and that will give you the final answer for the area of the pentagon. And make sure you label your final answer with square units. Let's revisit this example and find the area of the figure using method 2. And remember, method number 2 talks about extending the outside shape to create a bigger shape. So we're going to extend this horizontal line at the top all the way across and extend this left side up. to create one big rectangle. And then we know that this section of this new rectangle that we drew in, since the whole length is 12 and between these 2 points is 4, we know that the remaining length will be 8. And then we already know that its width is 2. So we can find the area of the whole rectangle as 12 meters times 8 meters, which is 96 square meters. And then we can subtract out 8 meters by 2 meters, which is 16 square meters. And then once we get both of these area values, we can subtract them and do 96 minus 16 to get 80. And that's the same answer that we found earlier. So whether you draw the horizontal line across here and add up the two areas, or extend the top and left sides out to create a big rectangle and subtract out the small rectangle, both methods will provide you with the same solution.